Imagine a tiny universe humming with activity inside your smartphone. This isn't science fiction, it's a neural network. These networks are the brains behind artificial intelligence. They power everything from facial recognition to language translation. Amazing, right? But don't worry, you don't need a PhD in astrophysics to understand them. Neural networks are inspired by the most complex structure we know, the human brain. Just like our brains learn from experience, so do these networks. They analyze data, find patterns, and make predictions. The more they learn, the smarter they become. It's like teaching a dog new tricks, but with less drool and more algorithms. Think about how you learned to ride a bike. It might have been a long time ago, but try to recall those first few attempts. You probably started with training wheels or maybe a helpful hand from a parent or friend. Remember the wobbly starts, the near misses, the eventual triumph? Each time you wobbled or fell, your brain was hard at work, processing what went wrong and figuring out how to correct it. The joy you felt when you finally rode without assistance was the result of countless adjustments and learning moments. Your brain processed information from your senses, made adjustments, and eventually mastered the skill. It took in the feeling of balance, the pressure on the pedals, the visual cues from your surroundings, and integrated all this data to help you stay upright and move forward. Neural networks learn in a similar way. Just like your brain, they take in information, process it, and make adjustments. But instead of learning to ride a bike, they might be learning to recognize faces, understand speech, or even predict the weather. They use math and statistics to find patterns in data. By analyzing vast amounts of information, they can identify trends and make predictions. This process is much like how your brain learned to balance and pedal simultaneously. It's like learning to ride a bike. But instead of pedals and handlebars, they use numbers and equations. These mathematical tools help the neural network understand and interpret the data it receives. Don't worry, you don't need to be a math whiz to grasp the basics. The fundamental idea is that neural networks, much like our brains, learn from experience. They get better with practice, refining their predictions and improving their accuracy over time. Imagine each neuron as a tiny calculator. Each one performs a simple calculation, but when you have billions of them working together, they can solve incredibly complex problems. It takes in information, does a little math, and sends out a signal. This signal is then passed on to the next neuron, and the process continues. Each step involves a small calculation, but the collective effort results in powerful computations. Connect billions of these tiny calculators together, and you have a neural network ready to learn. This network can process vast amounts of data, recognize patterns, and make predictions, much like how our brains process sensory information and learn new skills. It's like a massive game of telephone, but instead of whispers and rumors, they're passing along data and making predictions. Each neuron or node in the network contributes to the final output, ensuring that the information is processed accurately and efficiently. This collaborative effort allows neural networks to tackle complex tasks and provide valuable insights. Let's zoom in on these neurons. These tiny cells are the building blocks of our brain's complex network. They are responsible for everything we think, feel, and do. Each neuron receives input signals from other neurons. These signals travel through intricate pathways, forming a vast communication network. These signals are like votes. Each signal represents a piece of information, a tiny vote in the grand decision-making process of the brain. If enough votes say yes, the neuron fires, sending its own signal down the line. This firing is an electrical impulse that travels rapidly through the neural network. This process repeats, creating a chain reaction of calculations. Each firing neuron influences the next, creating a cascade of activity that underlies our thoughts and actions. It's like a democracy of data, where each neuron gets a vote. Every neuron has a say in the final outcome, contributing to the brain's overall decision-making process. These connections between neurons have different strengths called weights. These weights determine how strongly one neuron can influence another. Weights determine how much influence one neuron has over another. A strong weight means a strong influence, while a weak weight means a lesser influence. Think of it like friendship. Some friends have a strong influence on your decisions, while others, well, not so much. The same goes for neurons. Some friends have a strong influence on your decisions, while others, well, not so much. This analogy helps us understand how neurons interact and influence each other. Neural networks adjust these weights as they learn, strengthening connections that lead to correct answers and weakening those that don't. This learning process is continuous and dynamic. It's like making new friends and losing touch with old ones, but instead of awkward social interactions, it's all about optimizing for accuracy. The brain is constantly fine-tuning its network to improve performance and efficiency. During learning, the brain forms new connections and strengthens existing ones. This adaptability is what makes the brain so powerful and capable of handling complex tasks. This ability to adapt and change is known as neural plasticity. It allows the brain to reorganize itself, forming new neural pathways in response to new experiences and information. When solving a problem, neurons fire in a coordinated manner, working together to find a solution. This collaboration is what enables us to think critically and creatively. The brain processes information at incredible speeds, with neurons communicating rapidly to make sense of the world around us. This rapid communication is essential for our survival and daily functioning. When making decisions, neurons weigh different options, considering various factors before reaching a conclusion. This decision-making process is complex and involves multiple areas of the brain. The brain is also capable of adapting to new challenges, forming new strategies to overcome obstacles. This adaptability is a key feature of our intelligence and problem-solving abilities. By continuously optimizing its performance, the brain ensures that we can navigate the world effectively. This fine-tuning of connections is what allows us to learn, grow, and thrive. In essence, our brain is a remarkable organ, with tiny neurons working together seamlessly to create the rich tapestry of our thoughts, emotions, and actions. These tiny brains truly have big ideas. Layers of learning, like a cake, but smarter. Neural networks are organized into layers. Think of them like the layers of a cake, but instead of frosting and filling, they have neurons and connections. The input layer receives the raw data like an image or a sound. Hidden layers process this data, extracting features and patterns. Finally, the output layer gives us the answer, like identifying a cat in a photo or translating a sentence. Each layer builds upon the previous one, creating increasingly complex representations of the data. It's like starting with a simple sketch and adding more detail with each layer until you have a masterpiece. The more layers a network has, the more complex patterns it can learn. It's like adding more layers to your cake. It just keeps getting better and better. Learning from mistakes, even AI has to practice. So how do neural networks actually learn? It's a fascinating process that mimics the way humans learn, but with a twist. Through a process called training, neural networks are able to improve their performance over time. We feed them massive amounts of labeled data, like images of cats and dogs labeled with their respective names. This labeled data acts as a teacher, guiding the network on what the correct answers should be. The network makes predictions based on this data. Initially, these predictions might be far from accurate. If it gets it wrong, no problem. The beauty of neural networks lies in their ability to learn from their mistakes. The weights, which are essentially the parameters that influence the network's predictions, are adjusted, and it tries again. This adjustment process is known as backpropagation. This process repeats millions of times until the network becomes incredibly accurate. Each iteration brings the network closer to the desired outcome. It's like taking a test, getting a bad grade, and studying harder for the next one. The more you practice, the better you get. Except neural networks don't have to worry about failing grades or disappointed parents. They just keep learning and improving without any emotional baggage. This trial and error process is how neural networks get better over time. Each mistake is a learning opportunity, making the network more robust and accurate. The more data they are exposed to, the more accurate they become. Data is the fuel that powers these learning algorithms. It's like learning to play a musical instrument. At first, it might seem daunting and full of mistakes. At first, it's all squeaks and wrong notes. But each practice session brings improvement. But with practice, you get better, hitting the right notes more often. The same principle applies to neural networks. Neural networks just do it with data instead of musical scales. They learn patterns, make predictions, and refine their understanding with each iteration. Think of the neural network as a complex web of interconnected nodes, each node representing a neuron. These neurons work together to process information and make decisions. Data flows through this network, activating different neurons based on the input. The network adjusts its pathways to improve accuracy. Data scientists play a crucial role in this process. They design the architecture of the network, select the data, and fine-tune the parameters to optimize performance. The journey of neural networks has come a long way since the early days of AI research. Advances in computing power and data availability have propelled their development. Today, neural networks are at the heart of many cutting-edge technologies, from self-driving cars to medical diagnostics and language translation. Their ability to learn and adapt makes them incredibly powerful tools. As we look to the future, the potential of neural networks continues to grow. With ongoing research and innovation, who knows what new capabilities they will unlock. So remember, even AI has to practice. Through continuous learning and adaptation, neural networks are shaping the future of technology, one iteration at a time. From Netflix to self-driving cars, neural networks are everywhere. Neural networks are everywhere, even if you don't realize it. They're the reason Netflix knows what shows you'll love, why your phone can understand your voice commands, and how self-driving cars navigate the roads. They're used in healthcare to diagnose diseases, in finance to detect fraud, and even in art to create stunning images. It's like having a team of invisible experts working behind the scenes, making our lives easier and more efficient. The possibilities are truly endless. As neural networks continue to evolve, they're poised to revolutionize countless industries. It's like the invention of the internet, but with even greater potential to transform our world. Get ready for a future where AI is everywhere, making our lives healthier, safer, and more enjoyable.